What do burning wood, rusting iron, and photosynthesis in plants all have in common? They're all chemical reactions. Chemical reactions are processes in which substances change into new substances. There are 5 important types of reactions you should know. A combination reaction, also called a synthesis reaction, is when 2 or more substances come together to form a single product. Think of it like making a sandwich. Bread plus butter plus jam gives you one delicious sandwich. In chemistry, a good example is when hydrogen reacts with oxygen to form water. Many reactants combine to make one product. Now let's look at the opposite reaction, decomposition. This is when a single compound breaks down into 2 or more simpler substances. For example, heating mercury oxide splits it into mercury and oxygen. It's like breaking apart a Lego model into the original smaller blocks. One reactant gives you multiple products. A displacement reaction happens when a more reactive element replaces a less reactive element from its compound. Imagine a stronger player pushing a weaker one off a seat. For example, if we put zinc metal into a copper sulfate solution, zinc replaces copper because it is more reactive. The copper gets displaced, and zinc takes its place. In double displacement reactions, there is an exchange of partners between 2 compounds. It's like a dance where the partners swap. A classic example is sodium sulfate reacting with barium chloride. The result is barium sulfate, which forms a white precipitate, and sodium chloride. Another very important type of reaction is combustion. Combustion happens when a substance reacts with oxygen and releases heat and light energy. For example, when methane burns in oxygen, it produces carbon dioxide, water, and energy. Everyday examples include burning wood, petrol, LPG, and candles. When writing chemical reactions, it is important to balance them. This is because of the law of conservation of mass, which states that atoms cannot be created or destroyed in a chemical reaction. Therefore, the number of atoms of each element must be the same on both sides of the equation. To balance an equation, count the atoms of each element, adjust the coefficients, numbers in front of formulas, and make sure both sides are equal. For example, the reaction of hydrogen with oxygen to form water is balanced as 2H2 plus O2, 2H2O. Reactions can also be classified based on energy changes. An exothermic reaction is one that releases heat energy to the surroundings. The burning of fuels, such as methane, is a good example since it produces carbon dioxide, water, and heat. On the other hand, an endothermic reaction absorbs heat energy from the surroundings. A common example is the decomposition of calcium carbonate when heated to form quicklime and carbon dioxide. Photosynthesis in plants is also an endothermic process, as it requires light energy to convert carbon dioxide and water into glucose and oxygen. In summary, combination reactions involve many reactants forming one product, while decomposition reactions involve one reactant breaking into many products. Displacement reactions occur when one element replaces another, and double displacement reactions involve an exchange of ions. Balancing equations is essential to obey the law of conservation of mass. Finally, some reactions release energy, exothermic, while others absorb energy, endothermic. Thanks for watching, and if you enjoyed this lesson, don't forget to like, share, and subscribe for more science videos.